Howdy, everybody. Welcome in. Live from my basement. Not cliche at all. It is your computer science teacher here with what might be, in my opinion, and probably many other opinion, uh, one of the most difficult to understand topics in C++. It is something that is never taught at the high school level. It is rather difficult to understand, and I know I'm playing it up a bit, but even at the collegiate level, uh, these are sort of mystified. It is a topic we call pointers. In C++, one of the things that high-level programmers like about it is that it was created at a time before there was a lot of known territory in computer science. So back when C was developed in the early 70s. You could do a lot of stuff behind the scenes, under the hood, with direct addressing of memory locations. Like you're almost like assembly language. And so pointers are a way to look at the memory in your program. Now, admittedly, what you're about to see does not go into a lot of depth. Just want to get that out there now. This is not meant for an in-depth course on pointers. Those of you that are taking computer science someday in college, I guarantee you will see this at some point, especially like software engineering type majors. This is supposed to be the briefest and simplistic of overviews I possibly can give you, because some of the things you're going to be doing coming up this week with operator overloading is going to require you to understand just a teensy weensy bit of this. So I have a program I'm going to make called pointers. It's going to be on the desktop, so let's go ahead and create it. Unlike our class programs, this is just going to be a straight up normal CPP file. So just go to source code, add new item, just throw this little guy in here, add. All right, so like I said, pointers, whenever, period 2, 3, or 8, whichever you fall under. All right, let's just get this up and running. Oops, I don't want another one. I'm getting ahead of myself. Okay. Now, let's just do a couple of notes here. When you declare a variable, you're giving it a name and a type. When you initialize a variable, you also give it a value. So, something like int x equals 5, let's say, right? That's a declaration with an initialization. If you don't know that, I'm not sure where you've been for the last year and 3/4, to be honest. So, what does any of this have to do with this silly little thing that we're doing? So, when you do this, the program / compiler, like the whole works going on here, sets aside a memory location for your variable. This location has an address in RAM. RAM is random access memory. I know many of you probably know that. The two types of memory, you have RAM and ROM. The ROM, the read-only memory, is the memory that is kept when you turn your computer off. Your BIOS, for instance. Again, I don't want to go too in-depth here, but your RAM, like when you buy a computer, you typically, it's like, oh, it has 8 gigs of RAM, it has 16 gigs of RAM, it has 32 gigs of RAM, and so on. That's the description of the memory you can use while the program is running. So it's the amount of memory that Windows can take for the programs, the more the better, for the most part. So in your RAM, you can picture as this big map of your computer's memory. And so when you declare a variable, Visual Studio will go and say, okay, X, you're going to go here. It's almost like the front desk of a hotel. It's assigning a location to that variable. So as a programmer, how do I see that address? And that's where pointers come into play. So what I'm going to do down in my main function, I'm going to declare, let's say x. So, just bear with me. I know some of these comments are probably going to be a little bit tedious. X is an integer, right? Again, like if you don't know that, I'm not sure where you've been. Now, what I'm going to do is I'm going to say, where is x located? And to do that, I'm going to declare int and then asterisk. That does not mean times. It does not mean multiplication in this sense. I'm going to put x ptr. Now, we know variable names. Variable names do not have to be anything particular. I'm calling this xptr basically to have it be a good variable name. And Visual Studio sometimes likes to put the array brackets or the asterisk here. Just put it with a variable type. You can put it that way. I personally don't prefer it that way. I like to see it with the variable name, but So here, xptr is an integer pointer. Okay. Now I know we don't know what that is yet, so just bear with me. Let's keep going. So here, if I say x equals 5, kind of like we said above, what we've just said is we've assigned the value 5 to x. All right, that's cool. So if I print out x, again, I don't want this to be rocket science. Let me fix my spacing a little bit. We all know, at least I would sure hope so, we know that it's going to print out 5. Right? Like, why wouldn't it? Of course it does. So what about printing out, what if I print out xptr? And I'm just all great with my spacing here. I'm obsessed with my spacing. Okay, let's keep it consistent. So let me run this real quick. And I'm going to get this error. It's telling me it's uninitialized. Now, we know that if I didn't assign a value to x, right? Like if we declare a variable, but we never actually put anything in there, it doesn't like that, right? Sometimes, in certain circumstances, we can get that to work, and it'll give this like that weird negative number. Okay, but a variable needs something assigned to it. An integer variable needs a value of an integer. So that's what we did. We printed out as 5. Yay, that's exciting. So down here, we can't print out the contents of this variable until we assign it a value. So what we're doing is I'm going to say xptr. Notice there's no asterisk there. I'm going to say that that's equal to. Now this is where things start to tie together a little bit. The address of. Notice it's the ampersand. The ampersand is something we used in functions to pass by reference, because we're directly accessing the address of that variable rather than a copy of it. That's the relationship here. So if I say I want that variable to be the address of x, okay, this is assigned the memory location of x. And so now if I run the program, I'm going to get x is stored at a hexadecimal value. Does it matter what that is? No. Will it likely be different on your computer? Sure, it might be. We have different hotels. We have different RAMs. We have different computers. So maybe you have more RAM than I do. Maybe you have other programs running. So it doesn't have to be the same. Now, if we were in the lab, it would be pretty much the same. Like there might be a difference here or there depending on if somebody has something running. But if we were to do this on the same computer, it's going to be the same location. But again, what I'm trying to say is that the location is not so important. It gives you a hexadecimal value. It's saying this is where x is located. Hex value of the location of x. Now, you're probably wondering at this point, okay, so what? Right? It's like, okay, this is the craziest, weirdest thing. Who cares about the location of variables? And in most circumstances, I absolutely agree. It's the relationship between the asterisk and the ampersand which is important here. We know that the ampersand, going back up here, the ampersand gives you the address of a variable. Okay, so again, it's the memory address. The asterisk is what we call the dereference operator. Remember, operator is a fancy name for symbol, plus, minus, times, divide. Again, here, the asterisk is only a little prefix operator before the variable. You might remember us talking about operators, the whole idea of binary operators and unary operators. A binary operator is when you have one operator and then two things with it. Binary, two. So, like the plus sign is binary. It has 3 plus 4. There's something on the left, something on the right. The multiplication sign, 3 times 4. There's something on the left, something on the right. In that circumstance, the time sign is binary. So it's a different operator than this. This is unary. It only has one operand with it. So it has two different meanings. In this case, it is a prefix operator before a variable to symbolize that this is a special variable that points to this. And notice that I did integer, integer. Well, if you have like a double variable, you want to have a double pointer. If you have a character variable, you have a character pointer. So again, I'm not going to go crazy in depth with this. But let me show you where this does matter, besides what we're working on this week with operator overloading. Arrays. Arrays are where you see how all the Wizard of Oz, the curtain, you draw it back and you say, I see the light. So check this out. Let's make an array. Let's call it num. And I'm going to have num equal to just a couple numbers, like, I don't know, 5, 10, 15, 20, or something like that. Okay? Now, those numbers, because it's an array, it's not just a whole bunch of haphazard variables, it's consecutive memory locations. That's the key to this. So, if I say I'm going to make a variable, let's call it num pointer. And I'm going to say num pointer is equal to the array. All right? Watch this. I'm going to print out, what address is that? What address is the array located at? It is 00F8FA5C. Again, don't care about the actual address. But wait, there's more. But wait, there's more. If these are consecutive memory locations, what happens when I say, take the pointer, take the variable that stands for where this array is located, and go one space further. Go one space further. Just say, add 1. What do we get? We get 00FF6B8, 004FF6B6. Now, I think we agree, like, these first two, like, this is our 5. This is the location of X. Those are sort of close, but there's a little bit of distance. Like, from DC to B8 in base 16, that's a little bit of a difference. But here, those are pretty close, aren't they? 004FF6B8, 004FF6BC. In hexadecimal, I know I'm going all the way back to last year with base conversion, binary, octal, and all that stuff. In base 16, the letters A is 10, B is 11, C is 12. The difference, if you subtract, C being 12, 12 minus 8 is 4. Why does 4 have anything to do with it? Remember how big an integer is? What's the size of an integer? An integer is 4 bytes because it's 32 bits, 32 ones and zeros. An integer is 4 bytes. So how big was the memory location here? 4 bytes. This was different by 4 bytes. So it took 4 bytes to store the first number, but then the memory location beside it was the next 4. And so if I do all of my memory locations, if I say, okay, now go 2, and if I say now go 3, well, watch this. All of these, if you just do some quick math, 90, 94, 98, 9C. Apart by 4, apart by 4, apart by 4. They're all in a row. That's what makes an array special, is because they're assigned memory locations that are in order. Not just like, oh, there's int ABC. Like, they're just going to be all over the place if you do that. But making an array is special because they're connected. That's pointers. And as I said, this is the most simplistic, briefest explanation you're going to get. I only wanted to introduce it to you because it's going to be coming up with a couple little things with operator overloading, as well as what we're going to be doing coming up the next couple of weeks with sorting algorithms. So when you see that little asterisk, think pointer, which in summary, to wrap up our video, is simply a variable that represents a memory location of another variable. Thanks for watching. Have a great one.